Yellow. Welcome. Am I streaming? Welcome to 6502 assembly. Part 2. Am I streaming? I am streaming. Great. Does anyone hear me? Welcome. There's some audio. Okay, great. Alright. We're gonna continue where we left off on Easy 6502. Yeah, great. So where did I leave this? I was trying to figure out how this subtract root carry stuff worked. And I did, kind of. So I'm gonna try to explain it basically. So we kind of know how add root carry works. So I'm gonna, yeah, actually I have the data here, although I don't want this. That was a temp file. Where do I want to go? Do I have a folder? Yeah. Okay, let's go to my notes. By the way, let me see if the whole screen is visible this time. Because last time I streamed, I couldn't see the bottom of my terminal window. So I'm just trying to double check that you can see what I'm doing. Yeah, you can. Okay. Great. So now, that's the intro. Adding and subtracting. So these are these arithmetic operations that 6502 offers. And if you go to the tutorial, where's the content document? I think this is. I say this one is a good one. Yeah, a primer of 6502 arithmetic operations. So it has two operations: add with carry, subtract with carry. Addition and subtraction for single byte operands and results. So you can only add and subtract bytes. Then if you want to do 16-bit addition multiplication, you can basically chain these together. Yeah. However, operations are not limited to a single byte range, which is where the carry flag comes in. That's right. So you can just borrow with a carry. Just remember that this thing has a carry flag. It just has a 1-bit carry flag, which indicates if you're carrying something, and you can only carry one thing at most when you add stuff, by the way. So now people are like, oh, no, but you know, when you add oh god, one sec. Gotta mute my mic. All right, I'm back. Yeah, so people are like, oh no, but if you add like 99 plus 99, you have two carries technically, because I think, does that work? Almost. Yeah, because 99 is 18. No, actually I think in multiplication you get, let me think. Yeah, I think if you add, you can't get a carry of 2. Only in multiplication you can, but if you add 8, 18, 19, yeah, you can't, because if you look at this, the max value, that's 190, you can't get 200, let's say so. But independently of that, so yeah, independently of that, if you could think of even multiplication, you can carry more than one, but you're carrying one digit because it's a decimal system. So technically, it's one bit, so not a bit, but a, what is it, binary? What's 10 in some language? A tenary, tenit, whatever. The point is, you can you don't need much more. So if you have one thing to carry stuff in, worth one digit, then you're done. You can just keep doing that. So that's why this works. Anyway, so in order to accomplish this, they show how you can do it. So you clear the carry, you load something, you add something, and then now they explain how SPCs work. So an SPC calculates the result of A minus M minus something. Because if you think of, look at this operation first. This is addition with a carry. And this is minus this. So technically, if you can convert this, this is sort of the opposite operator where you borrow. So it's less of a carry, it's more of a borrow kind of thing. So you kind of set it when you want to, if you want a strict subtraction, you have to set the carry bit to 1 first, and then you do it. So for example, if you want 15 minus 8, as they say, you first have to set the carry in preparation, and then you do that. So if I kind of look at this formula, so that means not carry. So if you can look at it like this, it's something like 1 minus c, oops, plus 1 minus c. So that's A minus M plus 1 minus c, which there are many, it's like, so it's either A minus M minus 1, or if that's 1, it's A minus M. So this is the case. This is the case C is equal to 0, and this is the case C is equal to 1. Right. So you have two cases. You're either subtracting with M minus 1 or with M. Depending what you, if you want with M, you get that, and if you want with. Now the way to think about this is that I'm trying to see if there's like, if it's like the analog of add with carry. Like what, if I add something with carry and then subtract it, how can I get the same result back? Because technically what we know that A plus B minus B equal to A. So in our ideal world, we want add B sub B to be A equal to A, right? So if you have a Hoare triple here with A is A0, then you want, in this case you don't have a Hoare triple, but you just have a precondition and then postcondition. So basically you want, if you start with this, after this you want this. Of course, if you just do a naive add with carry, it doesn't really work. You can test it out here. So if I, okay, so let's load the value 80, which I think you can do. Works pretty well. And then you wanna ABC1 and then SPC1. Let's see what we get. You get 4F, which 4 times 16 plus 15, 79. So 4F is 79, or rather, you could have just done this, you know, whatever. You can see that you just don't get the same value. I got the wrong order. So if I load some number, you don't get, you get 1. You get always 1 less, unless this introduces a carry. So unless you have something like FF probably is the only value that introduces a carry on adding to 1. But if you have add 80 and you add 80 and then you subtract it, you get the same value. Exactly, because what happens is once you run add, you get carry set to 1, so subtracting is the clean operation. But otherwise you always get less than 1. Right, you do get less than 1, let me think. Actually, you would expect here to get +1, but I always get -1. Okay, there's an error in my thinking. Technically, I would expect 41 here because this is a smaller value, but that's not what's happening. Ah, it's the minus here. Right. Yeah. Missed the slide. So the idea is, yeah, that's the minus there. So this is you're either subtracting m plus 1, the value +1, or m, depending on the carry bit. So you only want to get that result back. So that's what we want, but that's not what we get. That's because if you look at ADC, you get A is equal to A plus M plus C. And if you can kind of look at ADC, SPC, you go A is equal to A plus M plus C, which then becomes A plus M plus C minus M minus 1 plus C, which is A plus C plus C plus C minus 1, which is A minus 1. Because 2C, no, that's not correct. So it's either ooh. Let me see where my thinking failure is at. But that's not the same carry bit. Okay. Oops. So that's the okay. So it's C0, A0. That's what you start with. Then you go ADC, let's say some value M. So this, I'll wrap this in this. Then the carry is now some carry value, and A is A plus M plus C0. And then you SBCM, and carry is I guess here you can go C1 and C2, and then the value is A plus M plus C0 minus M minus 1 plus C1, which, by the way, if I can sort of do this little equation, you get, well, first of all, the M disappears, so you get A minus 1 and then the sum of the carries. So if the first operation has no carry, and the addition, meaning if you start with no carry, and the operation also doesn't introduce a carry, so 3 cases. 1, start with carry and add, actually there are 4, let's go like that. Start with without carry and add without carry, you get a minus 1. A0 and then A0 and then A0. Start with carry and add without carry. So if you start with that, you get A and you get 0 with carry. If you start with carry and add with carry, then okay, I'm guessing now here you start with that set, so you get, at the very least, you get here 1. But what happens in this operation if this is 1? This gets borrowed actually, so that's 0. I'm thinking, and then start with without carry and add with carry, you get a 0. I'm thinking. Okay, let's see. We're gonna try all different cases. So we're gonna start by setting CLC. Okay. And this is the case we start with a carry. So this case we confirmed, but let's double check. So we are, no, that's interesting. So now that I did not expect. The carry flag is set in the first case. So you start without carry. Carry flag is set. So even though those are 0, this is 1 to reflect what has happened. Okay. Then you start with carry, but you add without, so that's this case. Okay. Again, do you get the same result? You don't? I'm confused. Or maybe I need to add it up. Maybe that's too early. Oh no. So you still get a minus 1, 1. Because I would have thought, what happens here? You would get 20. So, is that a real command? Oh, that clears it. I'm trying to set it. My result is wrong. SEC. Yeah, you get A and carry set to 1. That I got right. And if you start with a carry and add with a carry, so something like 80, 80, 80, you get a plus 1 without the carry, and start without but add with, you get 0. Okay, so I got these 3 right, but I got the first one wrong. Interesting. What I'm surprised is that this value, because you have two extra bits, so why do you end up with plus 1 only? That's kind of what gets me. Is that alright? I think the problem is that there's only so much you can carry. Because if you look at this, look. Probably has to do with Did it have to do with the value if I do 7f? Might be. Or maybe not, I don't know. So I think laptop is charging. So what I'm noticing, give me a sec. What I am noticing is that I guess there's only so much you can carry in one step. So for example, oops. So here, just ignore that. Okay. There's a carry. If I set it, I do get one more value. No, but this has overflowed, so no. This has overflowed so much. But you only get a, yeah, I mean you only get a carry, but if you overflow, is that true? No, that can't be true. When do you get a carry bit? Let's see, I need to, I guess so, no? So evidently, yeah, I mean, I guess on additions, the carry is only set when you overflow. Okay, so I still don't have a full intuitive answer, but at least I know the basic formulas, which is on addition, you use the carry positively, and then on subtraction, you subtract the anti-carry. I guess it looks weird. If you look at the formula again, probably you can't say you borrow the carry, because if in the carry is 1, you just don't use it. It's like you have an extra value. Okay, anyway, so you either have, yeah, that's the thing. So now we're gonna learn about branching, and this is when it gets fun. Branch are not equal. So let's look at this. So we are loading. What is all the x? We are loading x with the value 8. We can see that. Then you are decrementing by 1. You have 7. Then you are storing in x the value at 0 to 100. 0, 100, 0, 210, 0, 300, okay, 0, 200, okay, let's start again. Wait, set, okay. We decrement and then we store index x in memory. Okay, so you store 7 here. Then you compare x to the value 3. Okay, cpx. You compare to the value 3. And this comparison does what? Has to set some flag. Or what is it? What does it do? As if the carry was set, so it does a pure subtraction. Okay, now we see. You can have it for 3 cases. And so you use 2 bits. If it's equal both to 0, because the difference is 0. And okay, no, it's like this. For equals check, you just look at this, which means difference was 0. That's why. Here difference was non-zero, and the carry is 0 and the carry is 1 if it's positive. So this is positive, negative. Okay. So this should now set 0 and 1. So that should be 0 and this should be 1. Oh, no, or sorry, the carry, not the n. This is still positive. So. Okay, and then now if they are not equal, if this is not 0, you get back up there. So you store that in 6, you compare again, and you do this until they are equal. So now it's 3. Now we are here. Okay, that's 0, 6, 0, 6. 4. So this is 2-bit. This is the second instruction. This is the 4th instruction. Like this, and now we are in compare instruction. So that's why you have 0, 6, 0, 6. 0, 1, 2, 3, 4, 5. Oh no, wait. Ah, no, that's a 2-bit, so look at this. So that's LDX 08. Then this, then it's this, then this is STX 0200, and now we are here. And now it's going to be equal, so if I step into it, as you can see, 0-bit was set. A bunch of other things changed, but I'll figure that out. Ah, that's changing. And then finally, we will store that in the next thing. No, I mean, you take care of that, and now you store it. And you break, you're done. Why is ignoring the break? Yeah, whatever. Okay, so I see what happens. It's a thing moving. So you can kind of move. Yeah, I mean, the idea is going to be to do Snake, by the way, if you create a game. But that's fun. Okay. Yeah, now it's going to explain. So we load it, we decrement, we compare. Okay, you'll use labels, yeah. Oh, it's gonna be translated to an offset. Um, is there a jump instruction? JMP decrement. I think that does the same. Let's see. Not really. Ah, that's because this should be here. Yeah, that's the semantically the same thing. You unconditionally jump here and then you break. Okay, there's branch on carry clear. Oh, no, screw it. I don't wanna use it. Okay. Memory monitor, I do use it. Okay, all instructions that support absolute addressing also have the option to take a single byte address with the exception of the jump. Okay. Ah, so instead of doing 00 C0, just do C0. Oh, that's cool, because instruction is smaller than 0 page X. Ooh. In this mode, a 0 page address is given, and then the value of register X is added. Oh, so you can kind of do, you can do array indexing, like you say, this is address 0 and this is the index. Yeah, it's perfect. Ah, it wraps around. Very clever. 0 page Y. Can only be used with LDX and SDX. How does that work? Ah, some case. These are the absolute addressing versions, 0 page X, 0 page Y. Okay. Yeah, immediate. This is if you just use the value, so not memory location. And then relative. Oh. So that's this, and compare with 0, 2, branch, if not equal to, to 0, 2 from this, so 1, 2, that's I guess the next one? No. Obviously this is SDA. I guess that's break. But I'm trying to figure out if this is saying branch 02. So jump to instructions. So then that's 1, that's 2. Okay. Skip over the next 2 bytes. 1, 2. Okay, so from the end or from the here? Because 1, 2 would land you here. But this is saying from the end of this instruction, go 1, 2. So not from the operand. Okay, makes sense. Try editing the code so STA takes a 2 byte. Bum 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 bum. Yep, because it's saying from here 1, 2, 3, and then add up here. Good. Oh, pretty cool. I kind of don't like why they don't motivate why you would need this. I mean, with relative mode, it was obvious in some sense. Because you use byte and offset, or like address and offset, then you know it's like an array, but why would you need indirect? I guess pointers, yeah, but they don't motivate it. Indirect is like, go to this address to find this address. So it's like pointer to a pointer, basically. So if it's like, yeah, dereferencing a pointer to a pointer in C. Or rather, if you just have an int star p, you look at the value where p is, and then that's the value for the value. That's the memory for the value. So that's kind of what's happening in the dereference, yeah. So you load value 1, store this in F0. Okay, oh, no, reset, okay, debugger. So that's 1. Store this in F0. Load the value CC. Store this in F1. And you jump to the address specified here. Oh, and then in endianness. So CC01. And then would be nice to have CC as well here. Oh, in this case, because it's a jump, it's just saying go to memory. So this is like if you have an array of pointers and you dereference, like it's like if you have, let's say, something like that, and then you go A3 star. I don't know if this operation per se is possible. I think it is. Yeah, and you do that, and then that's what you get here. So you A, or you can also write this as star A plus 3 star, actually, again, because that's what A3 means. Is this? Yeah, so it's like tricky as hell. Alright, today I'm gonna keep it short. I'm kind of tired. This was interesting, but it's like nasty details until you can make something useful with it. But I'd like to program a few things. I need to do a few loops for next time. few basic functions like a Fibonacci would be very nice. And I think, yeah, Fibonacci would be a very good one. And a nice challenge would be to write. That's gonna be hard. Now to like compile some simple language to this. But that's difficult. Needs to be a simple language, like very simple. And then it would work, because I don't have so much. Yeah, don't have so much time. Okay.